Most do it wrong, but mastering filament calibration is the key to exceptional print quality. Horrendous, weak or low quality prints can turn incredibly clean, stronger and much faster with just a few tricks. I'll show you exactly how to do it for any filament printer and slicer, from beginner to expert in only 5 simple steps and no weird calculations. Let's get right into it. First, I would always use Orca Slicer for calibration. It has the best calibration tests for any printer brand and all results can be used in all other slicers. But this calibration even works identical or extremely similar in multiple other slicers as well. Inside Orca Slicer, make sure you select your correct printer and standard print profile. For the filament, we select the correct filament brand preset if available. For example, Polymaker PLA or whatever filament you use. If your brand doesn't exist as a preset, just use the correct generic preset and then select it in the drop-down menu like generic PLA in my case. Now at the top left corner, we have our calibration test button. If you don't see this, you might have to enable advanced settings or go to preferences and enable develop mode at the bottom. For our different calibrations, doing them in the correct order is extremely important, as some settings influence others down the line. If you are a beginner, the pressure advance and flow rate tests are essential. The more you do of the rest, the better. But I'll give you general recommendations for each point if you want to skip some. For highest print quality and tests, make extra sure your filament is dried and keep it dry in some airtight storage with silica beads. Use the colorless silica, as others may increase your cancer risk. Remember, being born a cancer is good, cancer in your lungs is bad. Let's start with the nozzle temperature calibration. The lazy but often okay enough approach is to use the middle of the brand's recommended temperature range listed on the spool or in the online datasheet. The best approach is clicking on calibration and creating a temperature tower in our previously prepared project. Just select your filament type or enter a custom range to automatically generate the tower. If we now hit slice and select temperature in the top right corner, we can see that the nozzle temperature increases by 5 degrees for each segment. If LAN in develop mode is enabled, Bamboo printers can directly connect to Orca Slicer to send prints. But you can always export the G-code for any printer and print it from the SD card via USB or your network interface. We'll print this out in matte white PLA and use top-down studio lighting to see every little line and defect. The wall surface at the front looks very similar across all temperatures. We get almost no stringing in the low and middle temperatures, but high temperatures show a little more. The small detail cones look cleaner for low temperatures, still good at 215 degrees and okay at higher temperatures. The bridging gets visibly worse at higher temperatures. In contrast, looking at the side shows better overhangs for higher nozzle temperatures. In conclusion, the overall best results for my filament are around 215 to 220 degrees. Keep in mind, for other filaments like the screen TPU, results may look quite different. Always choose the temperature with the best combinations of good overhangs, little stringing and clean walls. Bridging can still be improved with other settings. Also keep in mind that lower temperatures lead to less layer adhesion and weaker prints. If you have an acceptable temperature range, I would go for the higher temperature, which leads to stronger prints, higher max volumetric flow and speed later. Before we save our new value, create a new project and don't save or transfer anything, so no weird calibration settings get saved. In the new project, go to filament settings and enter your best temperature value. Then save it with a name we can relate to that exact filament in the future. Next up is max volumetric speed. This setting controls the maximum speed at which the filament can be pushed through the nozzle without creating defects. It's highly nozzle and material dependent and the most important factor for print speed and limits your real max speed, as your printer automatically slows down all moves that exceed this flow value. In Orca Slicer, make sure you have the new filament selected. If you are a beginner, you can keep the generic value or brand preset value. Calibration is always best, so we click on calibration and max flow rate. You can keep the standard test values for most filaments, but some like TPU might even need lower values. Rare cases, like high flow filaments, can sometimes even go higher than 20. But don't go too high. Very high values might clog your nozzle, and doing a second run is always safer. We'll again generate and print the model out. This time, we want to look for the first layer with defects. Defects are very obvious at the top, but my print also has slight line defects further down that are suspicious. Make sure to check the sides with the rounded corners as well. Some filaments will show a change in surface sheen, which indicates material degradation and marks the max flow limit. For very flexible filaments, look more at the round corners, as the defects in the middle can also be due to the unstable one-line geometry. Now we just measure the distance from the bottom to the first defect. My fancy digital caliper, I said digital, it reads exactly 33 millimeters. Let's go back into the slicer preview and in the top right select flow to show the flow for each layer. We now drag the slider down to 33 millimeters, which is our first defect height. If we start dragging the second horizontal slider, we can read the flow used for this layer in the box above, 21.4 in my case. We don't want any defects, so we'll subtract another 10 to 20% depending on how risky you feel. With that, our final value is 17 cubic millimeters per second. That's a 40% speed increase compared to the basic value of 12. If you like that detailed type of content so far, leave a like, subscribe or comment below. There's a lot more to come. Like before, create a new project, don't save anything, and add the new maximum flow rate to your filament settings at the very bottom. Then hit save to update your filament setting. If you are ever tired of calibration, check out the worry-free solutions this video sponsor PCBWay offers. PCBWay takes out any guesswork for metal 3D printing, CNC parts, custom PCBs and more. Just select your production process, upload a geometry file, then select your quantity plus material to get an instant quote for your custom part at an affordable price. Their quality and customer support were exceptional for my last order, and I can highly recommend them. Next up is Pressure Advance. Very important, but lots of people get it wrong. Pressure Advance is there to control the nozzle pressure during acceleration and deceleration, to prevent under extrusion and blobs, leading to one uniform print line on fast printers. This is what some printers do automatically at the start of each print. Doing it once manually is better and saves filament in the long run. If we press Calibrate and select Pressure Advance, we first select our extruder type. We also get 3 different test options. I would always choose PA pattern, as PA tower is weird to calculate or diagnose, and PA line can be quite build plate dependent. In most cases, we can keep the range settings as they are. Perfectionists can also do smaller steps. But flexible filaments like TPU can go up to 0.5 end value. Now the most important part, even professionals in my consulting get wrong all the time, is setting speed and acceleration correctly. In general, I would recommend using your outer wall speed and acceleration here, as those are the features we see the most. But if we have low max flow rate, of example 10 cubic millimeters per second, our printer will never reach this outer wall speed. To check our real max speed, we quickly right click, add any basic shape and make it very large. Now slice it and select speed from the drop-down menu. We'll pull the horizontal slider to the outer wall and check the speed in the box. This is the value you should enter for low max flow rate filament. Back to our high flow filament. We enter 200 millimeters per second, as we can really reach this value, and 5000 for acceleration. Let's generate the test and print it out. We'll also turn off the automatic pressure advance calibration just to be safe. Our test shows the used flow rate and acceleration in the bottom right corner. For this test, look at the corner with very little or no gaps. But we also want the corner to be sharp. This is our best corner and value. So we just follow the line to read the corresponding pressure advance value. Don't hesitate to choose values in between two if you think that's best. Now let's go back into our slicer, generate a new project, don't save anything, and go to filament settings to enable pressure advance and enter the new value. Then hit save to update your filament setting. For other slicers, This might be in a different location. For example, in Bamboo Studio, go to Calibration, select Manage Results and add your filament settings and a new pressure advance value, also known as factor K. Now under Device, we can press Edit Filament, select the correct one and use the correct K value. I like Orca's way a lot more. It's very important to keep in mind that this value is only perfect for one speed and acceleration. To be more precise, one flow rate and acceleration. For example, the same flow rate but a lower acceleration already leads to a different pressure advance value. The further off, the worse this gets. The easy fix for that problem is setting all speeds and accelerations to our calibrated values, except the top layers. This is what I do and is a good solution for most of us. But for small objects or overhangs, our printer will still slow down and then use the wrong pressure advance value, which can reduce print quality. We can still fix that, but this is for advanced users only. So feel free to skip to the next chapter or just listen. Flow rate is mainly influenced by speed, layer height and line width. But this is a huge rabbit hole. Adaptive pressure advance uses multiple PA values to model perfect values for different flows and accelerations in any situation. Currently, adaptive pressure advance only works with machines that have Clipper firmware at the core. It's best to check this for your individual machine, and this might also change in the near future. In the Calibration tab, we can add multiple speed and acceleration values. It's recommended to use a low speed, your highest speed, and at least one value in between. We'll also add the top layer acceleration and the outer wall acceleration. Usually, it's recommended to have at least 3 values here. In my case, this leads to 6 different test prints. Just like before, we select the best pressure advance value for each one. You know what to look out for at this point. We'll also write down the corresponding flow and acceleration in that order. We'll need that in a second. Back in Orca Slicer, enable Adaptive Pressure Advance and enter all collected values. One line is one set of values. Again, use commas for separation. You can also use half of your lowest PA value for bridges and enable PA for overhangs if your PA model works reliably. The Orca wiki says that this hasn't been tested with Bamboo Lab, so I tried it myself. Sadly, this little test cube shows multiple artifacts that are not present with normal settings. So at the time of making this video, this sadly doesn't work with Bamboo Lab printers. For Clipper printers, the results look exceptional, and I think a future update from other brands to support this would be amazing. Next up is flow ratio. Very important and simple if done correctly. The flow ratio controls how much filament is pushed through the nozzle to make a line that has exactly the correct line width. Too high values make our line too thick and low values too thin. This makes a huge difference in print quality. I would always use the flow test YOLO recommended, but you can also do the perfectionist version with smaller flow steps. Doing the manual calibration of your slicer by following each step is fine as well. I think the Orca version is easier to get right. But for the love of God, do not do any of these caliper flow ratio tests. They also measure layer wobble, inconsistent extrusion, and they are extremely susceptible to caliper measurement errors. Please don't do it. My inner German dies a little every time I see it. In Orca Slicer, we select the test, slice, and send it to the printer. Make sure any automatic flow calibrations are still disabled. For this test, we get 11 different values. We can immediately see over-extrusion for very high values, and still some over-extrusion for zero flow ratio change. Around -0.02 looks okay, and -0.05 shows under-extrusion gaps. We are looking for the sample that has a smooth surface and no gaps between lines. A slightly visible main ring is fine. -0.02 looks almost perfect, and -0.03 shows some very tiny gaps. So we'll just choose the value of -0.025 in between. Back in the Orca Slicer filament settings, we check our flow ratio and add the selected value. It's a negative value in my case, leading to 0.955 flow ratio. We enter and save our settings like before. We'll look at the huge quality difference in a minute. In very rare cases, the highest or lowest value might still not be enough. In this case, just add 0.05 to your base flow ratio and then run the test again. It's that simple. Next up is retraction distance, often overlooked but can have a huge impact. Retraction distance controls how far our filament is pulled back between different print lines, essentially leading to clean start and end lines. In the Orca Calibration tab, click on Retraction Test. Direct extruder printers can always leave the standard settings. For Bowden tube printers, set the end value to 6 mm and increase the step value to reduce the test print time. Like before, we hit OK and print it out. For this test print, our retraction distance increases with each ring. We are looking for the first rings that have no stringing or oozing blobs. Also make sure that the seam at the side is clear at this step height. Filaments can get worse with higher values, so always choose good lower values, but never 0. In some cases, high retraction values can also lead to tiny outer wall holes, which look extremely similar to wet filament errors. So really keep retraction distance low if possible. For my white filament, around 4 to 5 ring height looks best overall. Back in the slicer preview, we enable the code preview and collapse the line type window. Now we drag the vertical slider down to the best ring height. Then we look for this G-code line with a used retraction length at the end. You can alternatively use this formula for the same result, but that's completely up to you. In filament settings, we go to the Settings Override tab and enter the new retraction length. Then hit Save Settings one more time. Let's finally test our new settings compared to the old ones by adding and printing an Orca cube. We'll use the same print profile and also enable Don't Slow Down Outer Walls for all prints to make it a fair comparison. Let's start with our white PLA. We can immediately see way cleaner layer lines for the calibrated filament on the right, which is largely due to the correct flow ratio. The corners are sharp on both prints, as the standard pressure advance value is by chance the exact same as our calibrated one. This is rarely the case though. Our top surface also looks way better, and we can even hear the difference when I scrape it with my wooden finger. Under more natural lighting conditions, the calibrated filament looks almost perfect. Other slicer settings could improve this even more, as shown in my other videos. Keep in mind, we can also print 40% faster with the calibrated filament due to the higher max flow rate. The TPU filament went from borderline unprintable to excellent. We get no more blobs due to the correct lower max flow rate. Our top surface has no more under extrusion and looks extremely clean and smooth. We get sharper corners all around the print as well, due to the correct pressure advance value. The slight discolorings of the walls can be improved by reducing the fan speed for this specific filament, like shown on the right. This line right here is a shrink line. I showed how to fix this in my previous video if you ever struggle with that. Overall, the calibration made a huge difference for both filaments and is a big reason why my designs I upload online look clean in all my photos and videos. Thank you to everyone who supports my channel by downloading or selling these. Now a few more things to keep in mind are: different machines, nozzles or extruders lead to different calibration results. Don't just copy stuff you see online. The same filament, but in a different color, very often has extremely similar calibration results, but not always. Different brands always have different results. You can enter all calibration settings in any slicer. The names might just be a little different. And we only have to do calibration once for each filament. After that, keep all automatic calibrations off like shown. Try these tips for your own prints and comment below if this video has helped you out. Click here for more videos like this one, and thank you for watching. Still here? There are plenty of other videos with cheap jokes just waiting for you to click on them.